Team, is Mr. Z doing another skill video, and this day we're going to look at inverses and how to sketch them. Let's jump on in. Okay, so the idea behind this is that we're going to go ahead and graph this inverse, and we're going to do it by doing the following. So I know an inverse is when I switch my x's or y's and vice versa. So what I'm going to do is first I'm going to graph y equals negative x squared. So this is for my original equation. I'm going to go ahead and create an xy table for when y is equal to negative x squared. So let's figure out some x's and y's. Now I'm going to always test the same critical points, -2, -1, 1, and 2. The reason I select these is A, they're on the coordinate graph, and also there's a mix. There's some negatives, there's some positives, and then there also is 0. So by repeatedly substituting this guy in, for example, I'm going to do y is equal to negative 2 squared. Negative 2 squared is going to produce a positive, so it's going to be -4. I'm going to do it again. I'm going to plug in y is equal to negative, plug in -1 squared. Y is going to be -1. I'm going to plug in 0. 0 squared is just going to be 0. Y is equal to negative times 1 squared. Y is going to be just -1. And then I'm going to plug in -2, or just 2. 2 squared is going to produce -4. So this is just me repeatedly plugging in my inputs. My first input, what happened when I got -2? I got -4. When I plugged in -1, I got -1. When I got 0, it produced a 0, and vice versa. This means for my original, I have the following coordinates. Now, in order to graph the inverse, remember, I have to replace all of the x's with the y's. Notice this coordinate is an xy, so my inverse is going to be just y comma x. So my original guy, let me graph it just for some reference. -2, -4, -1, 0, 1, -1, and 2, -4. Just as we expect. It's concave down because A is a -1. It's a parabola because it's to the second degree. Y comma x will be -4 comma -2, -1 comma -1, 0 comma 0, and -1, 1, -4, 2. So this produces a multitude of points. When I plug in -4 in, I get -2. When I plug in -1, I get -1. When I plug in 0, I get 0. -1, 1, and then -4, 2. Boom. This is a sketch of my inverse. Some extra bit of information is notice that my original function is to an even. That suggests that it fails the horizontal line test, which means that the inverse fails the vertical line test. So this is going to be the idea on how you graph the sketch of an inverse. You find the coordinate points of the original, and then you flip them. I'm going to use -2, -1, 0, 1, and 2 in this next problem. So my job is to figure out my x and my y's for when -2, -1, 0, 1, and 2. So what is going to be my first x value? Well, y. My output is going to equal -2 to the third power minus 2. -2 times -2 times -2. When I write it out, multiply the first two together, and I get +4. I multiply the second ones together, and I get -8. I'm going to do this again. Y is equal to -1 to the third power minus 2. -1 times -1 times -1. Multiply the first two, that makes a +1 times a -1. Multiply those two together, gives me a product of -1. Oops, I did forget in that first one, and I'm going to go back. Notice how it's also -2. So it's actually going to be -10. Likewise, this guy's going to be -1 minus 2, making -3. I almost forgot the transformation. This guy got shifted to the right. I'm going to repeat this over and over. Y is equal to, well, 0 to the third power minus 2. Well, that's just going to be 0 minus 2. Y is going to be -2. Let me do another one. When x is 1, y is equal to 1 to the third power minus 2. 1 times 1 times 1 is going to just be 1. Take away 2. My final one, y is equal to 2 to the third minus 2. 2 times 2 times 2 is a +8 minus 2. Y is going to be 6. And I can graph these: -2, -10, -1, -3, 0, 0, 1, -1, and then 2, 1, 2, 3, 4, 5, 6. This is the graph of my original. Now, before I graph my original, I know that this is a function because it passes my vertical line test. What about the inverse? The inverse is not going to be a function. Or is it? So now I'm going to keep on going. So let's keep on going this adventure. All I got to do is switch my x's for my y's. So my points for my inverse are going to be -10, comma, -2, -3, comma, -1, -2, comma, 0, -1, comma, 1, and then 6, comma, 2. -10, comma, -2, -3, -1, -2, comma, 0, -1, 1, and then 6, 2. Oh, I know why. I said that this guy did not pass the vertical line test. 0, -2, and then it's 1, -1. There we go. I knew there was something up. The reason I was able to determine that is this actually passes the vertical line test. That means the original should pass the horizontal line test. All right, one more and practice makes perfect. Oh my goodness. To the 4th power. So what I'm going to do is I'm going to plug in my numbers when it's -2, when it's -1, when it's going to be 0, 1, and 2. Now the only difference is I see that 1/2. So I'm going to actually just make all of my numbers even. It might cause it to be off the graph, but like for example, when I plug in -2, notice what happens when I plug in the even input. 1/2 of what? -2 to the 4th power. Well, -2 times -2 times -2 times -2. This is going to be +4. These two are going to combine to be +4, and those two are going to be 16. Y equals 1/2 of 16, which is going to be 8. Notice how an even input was nice. Watch what happens when I put a odd input in. Y equals 1/2 times -1 to the 4th. -1 times -1 times -1 is going to be very similar to what we just did. The first two are going to multiply to be a +1. The second two are going to multiply to be a +1. Now I need to multiply them, and they're going to be 1. So that means I'm left with 1/2 times 1, which is just going to be 1/2. So I just wanted to gain awareness. When you see a fraction, you usually want to use something that will be a multiplier of it because it's usually easier to graph. In this instance, this is fine. We're going to proceed. So I plugged in my -2. I'm going to plug in my 0 now. Y is equal to 1/2 of 0 to the 4th power. That's going to turn into just 0 times 0 times 0. It's going to leave me with 0. My next one, y is equal to 1/2 times 1 to the 4th power. 1/2 times 1, which is going to be 1/2. And my last one is when I plug in 2 to the fourth power. 2 to the fourth power is going to be 16. And half of 16 is 8. Again, I just want to kind of tell you, when you're dealing with fractions in your equations, you usually want your inputs to match. Notice how here the even inputs, when I take half of an even number, it works out, aka they're all multiples of 2. So like if I had 1/2, I would use 2, 4, 6. Those would make nice inputs. If I had 1/3, I would use 3, 6, 9, 12. If I had 1/4, I would use 4, 8, 12, 16, and so on and so forth. Time to finish this guy out. Our work has been done for us. Let me graph it and let me make sure that I'm precise as not to screw up as I did last time. -1 over, and then it's halfway between 0 and 1. 1 and 1/2, halfway between 0 and 1. And 2 and 8. Notice that this is an even power, so it's kind of like a flat U. It's like a boat. And then the idea is that since it's even, I know it's automatically going to fail the horizontal line test, meaning the inverse is not going to be a function. When I write my inverse out, well, -2 comma 8, -1 1/2, 0 0, 1 and 1/2, and 2 and 8. Let's flip. Switch my x's for my y's. Boom. 8, -2. I go 1/2 over and then 1 up. 0 0. I go 1/2 over to the right. Oh, that one's supposed to be negative. Good thing I caught that. And then 8 and 2. It's usually not the big errors that get you, it's those small ones. And voila. This takes some time. Figuring out all the coordinates is the difficult part. But that's been it. I hope this helped. Good job.